So in yesterday's lecture, okay, are you guys seeing my slides now? Can you please respond for that?
Yes.
Yes.
Yes, madam.
Yes.
Yes.
So how's the sound so far?
Good.
Okay, madam.
Good.
Okay.
Good,
Okay,
good.
madam.
Okay, so in yesterday's lecture, we have learned about concentration. Okay, sorry, we have learned about solution. So what are the components of solution? So basically we have two components for solution. One is solute, the other one is solvent. Okay, so when these two combine, it will form a solution. Okay, all right. So there are several ways to describe a solution. Okay, so in general, we can describe a solution in a form of concentration. Okay, so the concentration of a solution can be expressed in terms of, so there are a few ways to express concentration of a solution. So the first one, or the most common concentration expression used in chemistry is known as molarity. Okay, it is known as molarity. So the formula for molarity is equal to the mole of, N is the number of mole. Okay, so it should be the mole of solute there. Okay, it should be the mole of solute. And then here, volume here, okay, it should be the volume of solution, the total volume of the solution. Okay, so please take note on this. Okay, you have to specify. Later on, we may have a mole of solvent, mole of solute. Okay, so which one that need to be put into the formula? Okay, so for molarity, it needs to be the mole of solute, and the volume need to be the volume of solution, not volume of solvent, volume of solute or whatsoever. It should be the volume of solution, and the unit should be in liter. Okay, right. So that is for molarity. Next, we have another expression, other than molarity. So we have mass percent, okay, weight per percent, and then we also have volume percent, okay. And next we have a mixture of mass and weight or mass and volume, okay, percent mass per volume. All right, so these are another method ataupun another way to express concentration. Okay, right. So next, we have molarity. Okay, so molarity is almost similar to molarity. Okay, but the difference is in terms of the denominator here. So for molarity, for molarity earlier, okay, the denominator should be the volume of solution. But for molarity, it needs to be the mass, and it should be in kilogram of solvent. Okay, all right. So meaning that you have to make sure that the value that you are taking, make sure that it is for solvent, and then the value should be in kilogram.
Madam,
Yep.
attendance dah keluar.
All right. Okay. So I give you 1 minute for that. Okay. So go ahead and confirm your attendance. Okay, so let's move on to our lecture. Okay, so let me check how many of you are in the session at the moment. So we have 51 minus 2, that will be 49 of you. Okay, 49. Yep. Okay. Okay, so last but not least would be the mole fraction. Okay, we can also describe a solution based on mole fraction. Okay, so mole fraction is equal to mole of the solute, our interest solute, okay, over the total mole in the solution, including the solvent. Okay, right. So we have discussed about the example. Okay, we have discussed the example yesterday. The first example here, and then we also have another example. Okay. This is very straightforward question. Calculate the molarity and molality. 1, 2. Okay. Of a solution prepared by mixing 17.2 gram of ethylene glycol. So ethylene glycol is your solute, and H2O is your water. Of course, it's water. It's your solvent. Okay, so given is the mass of solvent in kilogram to make 515 milliliter of solution. So this is the volume of solution. Okay, so determine the mole fraction of C2H6O2. Determine the mole of solute in the solution. So there are 3 questions that we have to address here. Okay, all right. So molarity. Let's go for molarity first. Okay, so you may use your what we call that formula as your reference. Okay, to make sure that you are on track. That you are not looking for other information that is not necessary. Okay, so it would be helpful to have your formula written. Okay, so N solute over volume of the solution in liter. Okay, all right. So the mission now is to find out the mole of the solute and then the volume of the solution. Okay, all right. So obviously the mass of the mole of the solute is not given directly. Okay, so you have to change, but the mass is given. The mass of the solute is given. So you may calculate the mole. So this is the part where you calculate the mole. Okay, so we got 0.277 mole. Okay, so next would be the volume of solution. So we have this one ready already. Okay, we have that one. So next will be your volume of solution in liter. Okay, all right. So we need the volume of the solution. So this is the volume of the solution, and it is in milliliter. So you have to convert into liter. Okay, you have to convert into liter. Okay, you may use this 1 mil over 0.01 liter over 1 mil, or you may if I were to decide which one I would use, I would prefer to use 1 liter is equal to 1000 mil. Okay, so, but that is the one that I've been memorized since in school kan. So kalau 1 mil, that means you have to convert into 1 liter kan. So let's just pakai this one 1000 mil. Because what we need to be careful of is the unit. The unit should be the same, but the value, as long as they're related. Okay, so up here will be 1 liter. So you will still get the same answer. Okay, all right. So we have these 2 information ready now. Okay, we can calculate for the molarity. Okay, same goes for molality. Okay, we have the everything ready now. So we're gonna be using the mole still. Okay, and then next would be the mass of solvent, which is this one. This is molarity and this is molality. Okay, you can use it as the unit Okay, it can be molar or mole per liter. Okay, that means mole of solute per 1 liter of solution. Okay, or for molality, it can be molal or M, small letter M, or mole per kilogram of solvent. Okay, so this unit is helpful in telling us what are the components, okay, the amount of, for example, solvent and solute in the solution. Okay, and for mole fraction, so to calculate mole fraction of the solute C2H6O2, okay, the formula is mole of C2H6O2 divided by mole of solute plus mole of H2O. Okay, so we have this already just now. We have used the mole of solute for molarity and molality. Okay, this one too. And now we have to find the mole of H2O. Okay, so this is mole of H2O. Right, so given the mass of H2O is already given kan, dia bagi 500 gram. Yep, of H2O. So we can convert into kilogram. We can, no, given is in kilogram. So we can convert right away into gram. So it will be 500 gram. Okay, so find out the mole. So gram H2O, so it will be molar mass. So up here we have 1 mole of H2O. So cancel out, you will get the same value, 27.8 mole. So we have all information now, so we can insert the values and calculate for the final mole fraction of solute. Okay, so that would be the second example for concentration expression. So we have checkpoints. So we have 2 checkpoints for concentration and expression. Okay, so after we have covered the last subtopic, which is subtopic 1.10, okay, we will come back to this checkpoint. Okay, if not, please make sure that you complete the checkpoint, and later on you have to submit the checkpoint. Okay, all right. So we have few checkpoints. So the checkpoint can be quite tricky, especially when it involves molarity and molality and density. So density, we need density, okay, in order to help us to give extra information. Okay, so please take note, the formula of density is equal to mass of solution, okay, not mass of solute, not mass of, it can be mass of solute, it can be mass of solvent, but in this case we are referring to mass of the solution because we are describing the solution. Okay, so maybe previously you may have known density as mass over volume, that's all. Okay, so the thing about this is, the problem about this is the mass can be the mass of solute. Okay, it can also be the mass of solvent or the solution itself. So you do not specify which mass and which volume you are referring to. Itu yang problemnya tu. You tak tahu which entity yang you are referring to. That's the problem. Okay, so the density here is representing the mass of solution, guys. The mass of solution divided by the volume of solution. Okay, because in order to use this can be our conversion factor. Okay, you need to have the unit. Kita kena tahu the unit tu. Sebab it need to be matched. Kan? Atas dan bawah later on. So it cannot be matched mass of solution dengan mass of solute. Tak boleh. Okay, dia tak boleh match macam tu. This is not tambah tolak punya operation. This involve multiplication and division. So in order to be cancelled out, the unit need to be the same throughout. Tu masalah student adalah dia bila hafal dia tahu mass of volume. Okay, so now it involve a lot of things. So we have solute, solvent, and solution. Which mass you are referring to? Okay, so that's the thing yang you kena take note lah. Alright, so we have that, So you try to complete them first. Okay, try to complete them first based on what you understood from our lecture. Okay, we may have several methods to what we call to solve the problem. Okay, some people may prefer using this method, and some others may prefer to use other method. As long as it is logical and it is justified, ataupun you have reason for your why you go for this method instead of the other method, it's okay. Because science is all about logic and you have reasons for that. Okay, when we are talking about science, dia kena ada reason. Okay, kalau you are not able to explain why did you use this, why did you use that, okay, that means your method would be high possibility, ada kemungkinan salah. Okay, alright, so let's wrap up our topic 1, okay, with our very last subtopic, which is subtopic 1.10, solution stoichiometry. Okay, we already learned about this in our previous slide. It's actually the same thing. Okay, so the stoichiometry is the link ataupun the relationship that we have in a balance equation normally. Okay, so that link the reactant and product and reactant, reactant and product and product, and also reactants and reactant. Okay, right. It's just that for this time around, for this subtopic, what we want to highlight is that the stoichiometry or the reaction, okay, the reaction involve solution. That's all. Okay, the reaction involve solution. So previously, if you can recall, the problems ataupun the questions only involve substances in solid state. Like for example, what we have in limiting reactant so far, right? We have all the substances, all the compounds in solid state. Okay, sebab what we are trying to highlight is not on the state of the substance. We are trying to highlight the limiting reactant terms, the terms of limiting reactant itself. Okay, but for the reaction, it can involve in combination of all the state. It can involve gas, solid, and solution. Okay, so solution stoichiometry, this topic is just to highlight that that some reaction may involve solution in it. Itu sahaja. Okay, nothing new, itu sahaja. Alright, so we have one learning objective. Okay, by the end of this subtopic, you should be able to solve problem, okay, related to solution stoichiometry. So there are 4 types of reaction. Okay, 4 types of reaction that can involve solution stoichiometry. Okay, so example of reaction, we have gas formation reaction, gravimetric analysis, acid-base titration, redox titration. Okay. Okay, let's look at one by one. Okay, gas formation reaction. That means from the name of the reaction itself, okay, the reaction produce gas. Okay, all right. So maybe we can look at the example. When excess of sulfuric acid react with X gram of zinc ataupun unknown mass of zinc, 500 ml of hydrogen gas is evolved at STP, at standard temperature and pressure. Calculate the value of X. As you can see, we have sulfuric acid there. Okay, so sulfuric acid is in solution state, kan? So like I said just now, it's actually the reaction that involve solution. That's all. Okay, how we go about in solving the question is actually the same as what we have learned earlier. Sama je, cuma nak highlight, oh dalam ni ada solution. Okay, we have the balance equation ready here. So at the end of the day, you have to link them based on the mole. Okay, so in order to use the balance equation, we need the information in mole. So if you are given the sulfuric acid, maybe another type of question lah kan. Okay, you are given the solution, you need to extract out the mole in order to link them stoichiometrically. Okay, so like, okay, boleh nampak lah dekat sini. So we have to find the mole. What we need is the mole. Okay, because the mole is the one that can relate between the reactant and product for the balance equation, in the balance equation. Okay, all right. So please bear in mind that limiting reactant can also be asked involving solution. Involving solution. Okay, so what we had earlier, kebanyakannya involve only solid form and gas maybe. Okay, so once you have learned about solution stoichiometry, that means your limiting reactant may involve solution. Okay, alright. Tapi the method, the approach in finding the limiting reactant sama sahaja. You need to check for each reactant. Okay. Alright, so we have checkpoint for that, for this type of reaction. The next will be the gravimetric analysis, another type of reaction. Okay, so this is a reaction. It is actually an analytical technique based on the measurement of mass. Okay, in which we dissolve unknown substance in water. See, nampak tak? This is the method ataupun the technique used to produce a solution. When we dissolve something in a solvent, okay, ataupun in a solution, so we are creating a solution there. So by right, we should have concentration involved. Okay, again, they involve solution. So and react it with known substance to form precipitate. So in this type of reaction is known as gravimetric. It is based on the mass. Okay, we have an unknown substance and then we react with known substance and then this reaction will produce precipitate. So this type of reaction is known as gravimetric. Okay, so this reaction involves the formation, isolation, okay, formation of the product, and then or precipitate, okay, and then we have to isolate and dry the precipitate, and then lastly we have to determine the mass of precipitate. Okay, sebab they mention specifically to form precipitate. Yeah, this is the example with respect to the reaction just now. Okay, all right. So we have a gram sample containing lead and tin, and then we have sulfuric acid also there. Okay, so this is the solution that we are using, and also PB. Okay, they mentioned dekat sini 3 gram of an alloy was dissolved in nitric acid. So they dissolve when it is dissolved in a solution or in a nitric acid is a solvent lah in this case. Okay, for this alloy. So when it dissolves, so it has a concentration involved. So how do you describe the concentration? Okay, and then how do you link them? So bila dia dissolve, this is the reaction that may takes place. So the ionic compound, okay, the ionic part of the compound will dissolve and separate into its ions, and so on lah. Okay, so the question is asking for apa ni? Determine the percentage of tin in the sample. Okay, in the sample. Alright. So we have checkpoint for that. Okay, as you can see, the question can be quite long. That means there are process involved. Okay, so there are process involved in producing whatever lah dia nak produce dekat situ. But yang scariest part is to understand the whole process so that you can plan for your working solution. Itu yang paling scary. Kena pula tak faham soalan. Itu yang paling takut. That's why you have to practice more. Okay, right. Okay, let's finish all the reaction first. Hope we have extra time to go back to the checkpoint. Acid-base titration. Obviously, acid is in solution form, same goes to base. Okay, so these two can be reacted through titration technique. Titration is a technique to react acid and base. Okay, all right. So as you can see from the question, we have sodium hydroxide solution. So this is the molarity, and then we have the acid also, the molarity and the volume are given for acid. This is the formula. This is the what we call the balance equation that takes place. Okay, the reaction that takes place. For acid-base titration, we may use this formula. MAVA over MBVB is equal to A over B. A is stand for acid, B is stand for base. So by now, you should be able to, okay, let's just use for acid-base titration, just use A and B, okay, as your alphabet for the formula. But for dilution, okay, let's just stick to M1V1 is equal to M2V2. Okay, it's actually not the same. Okay, formula ni tak sama tau dengan formula M1V1 tu is equal to M2V2. The concepts are totally different. Okay, because the formula for acid-base titration, it depends on this ratio. Okay, if this ratio is 1:1 ratio, where did we get this from? This ratio, we can get it from the balance equation. Okay, if this ratio is 1:1, that means the acid and the base is the acid and the base reacting, they are 1:1 ratio. That means then only it will become MAVA is equal to MBVB. Okay, it's because of this is equal to the ratio of A and B, the ratio of the coefficient for acid and base is equal to 1:1, then only it will become MAVA MBVB. But for M1V1, this is for dilution. Okay, it may look the same. Okay, nampak macam sama, but the concept is totally different because we are talking about dilution. That means the mole. Okay, the before and after, the mole will remain the same. Dia tak mention anything about reaction at all. Okay, so MAVA MBVB is for reaction between acid and base, but M1V1 is equal to M2V2 is not a reaction, it's a dilution process. Tahu tak? Dia based on mole. Okay, mole before and mole after the solvent has been added, they are the same. That is what dilution is. So jangan, student at the end of the day memanglah sama, dia punya ni sama kan. Tapi understanding the concept is not the same. Faham ya? The reason why we got this is because of it is 1:1 ratio. If it is not 1:1 ratio, it become like this, then it will not be the same as MAVA is equal to MBVB B. It will not be the same. Okay, so how can you use the formula is the same? Ya, formula wise mungkin sama if okay, provided that the ratio is 1:1. Okay, alright. So you can insert into the formula, or alternatively you can use dimensional analysis. Okay, using the dimensional analysis where we can link the ratio of the acid and base. Okay, pakai dimensional analysis. After all, okay, this formula is apa nama tu, a simplified form of apa nama tu, method, like for example dimensional analysis tu, simplified form. Okay, they simplify and form a formula for acid base titration. So conventionally we use the apa nama tu, 1 mole of this react with 1 mole of that. So which is in dimensional analysis can also be used. Okay. Right, so we have checkpoint for that also. Okay. Next up, we have redox titration. This will be the last reaction, okay, that we can apply the solution stoichiometric. So the word redox itself, okay, RE stand for reduction, RED, okay, and OX stand for oxidation. Okay, it is the reaction, oxidation and reduction reactions occur simultaneously. So the technique used is still titration. Okay, it's basically the same as what we have for acid-base titration. It's just that the reaction here is known as redox reaction. For acid-base titration, the reaction is called a neutralization reaction. Okay, the process involved is neutralization reaction. For redox, it is called redox, oxidation and reduction reaction. Okay, so it involves titration. So we will be based on equivalent point. Okay, because if we are using the burette, so titration requires burette as one of the apparatus, one of the glassware. Okay, if you are using that, that means we need to have the equivalent point, so that we will be able to know when to stop titrating. Kalau tak ada indication that, how do we perform the titration? Okay, so it will be difficult lah. Bila nak stop ni? Kan? Kita keep on adding the solution from the burette and then we do not know when to stop. So itu problem lah. Okay, for acid-base titration just now, we may have our indicator like phenolphthalein. For redox titration, the chemicals used, the reducing agent and oxidizing agent itself has a color. Okay, dia sendiri apa nama tu, colored solution, colored. So for example, if the initially the color is purple, okay, after the reaction has taken place, the color may change to light pink. So it shows that, okay, we can stop titrating now. Okay, we can stop the titration now. So that is the indication that help us to apa nama, to stop the reaction and to finally identify that the reaction has completed. Okay. So these two are the most common oxidizing agent. Oxidizing agent, that means they oxidize others. Okay. What is the indication of oxidizing agent? Okay, due to the presence of oxygen in the species. Okay, nampak tak ada oxygen dekat situ? It has a lot of oxygen. That means it uses the oxygen to oxidize others. Okay, so that's why this is an oxidizing agent, very strong oxidizing agent, in fact. Okay, all right, so we can still use the MAVA MBVB is equal to A over B. Okay, so this is an example of question. As you can see, we have the what we call this, the equation involved. Okay, all right, so you can use the formula or you can also use the dimensional analysis method or your conventional method, but make sure provided you tailored lah dia punya tu 5 mole of iron 2 plus will react with 1 mole of manganate ion. Okay, if you go for your conventional method. Okay. So we have checkpoint. We have checkpoint for each of the reaction type. Okay, just to expose yourself with the type of question that can be asked. As you can see, inilah macam inilah pattern soalan. Okay, so it can be quite long. Okay, and it kalau based on dia punya length of the question, that means it take time for you to understand the question. If you do not understand the question, then how can you proceed with the working solution, kan? You have to understand the question first. Yep, that's all for topic 1. So these are the list of references, okay, that has been referred to. So some of the content were taken from Ebbing, okay. So these are the textbooks. Kita tak katalah kita guna entirely kan. It's a mix of textbooks lah basically. That's why I at the beginning of the semester last time kan, I do not restrict you in terms of the textbook. Okay, you may use any textbooks that is setara Okay. Yep, that's all for topic 1. Alhamdulillah. Okay, so any questions so far, guys?
Madam,
Yep.
kalau buat yang balance equation tu nak kena bagi tahu ke keadaan dia aqueous ke solid ke?
If the information is provided, that means you have to include lah. The good practice is to include. But for topic 1, it's not insisted lah. Okay, it's not insisted. Maksudnya kita tak insist lah on the type, on the state of each of reactant and product. Dia ada topik dia tau yang kita insist. For example, topic 5 later on, the state will be insist. Maksudnya without the state, your mark will be deducted. So takkanlah during that time you baru nak start include the state kan. So make it a practice, start from now so that you are familiar, okay, with the bukan familiar, you are used to it, okay. That become your habit, okay, when you have the balance equation. Tapi the thing about balance equation ni, the state, you have to have the information lah. By right, the question need to give out that information. Sebab some of the compound can be quite difficult to determine the state. Kalau water tu, even water itself we have 3 states kan. Pun nak kena tengok condition dia. Kalau dia punya temperature is 200, that means it will not be in liquid form. So you have to use gas kat situ. Okay, so there's a lot of things to be considered. So by right, the question should provide, unless the reactant ataupun the substance used are common, okay, and then given the temperature is provided, that means you boleh determine. For water, for example, just now,
Thank you, madam.
Alright. Any other question, guys? Okay, alright. So we have 3-4 minutes ke macam tu. Okay, maybe you can try to, okay, let me see mencabar sikit ke. Maybe you can try out try on your own. You may have the answer, but you have to try it on your own lah. Try A lah, A. Okay, cuba try A. Try to answer question A. Boleh tak buat? Ni dah boleh ready for your midterm test because you have completed all the subtopics. Maksudnya you can sit for your test. Yep. Okay, midterm test covers only topic 1. So that is a very good news. Okay, it only covers topic 1. So we have completed topic 1. So we have like few more weeks before our midterm test. Okay, so by right you should be prepared lah. Okay, during the midterm test, everything should be in your, at the back of your, apa nama tu, senang cerita you mesti dah ready lah sepatutnya. Okay, sebab it only covers topic 1.
Madam,
Yep.
ni my question is related to the previous stoichiometric question. Kalau nak cari limiting reactant, kalau dia punya balance equation tu ada 3 reactants and 3 products. So nak cari macam cara yang kita belajar sebelum tu kan ada cara lain. So, macam panjang je kalau nak bandingkan.
Yeah, it can be quite long. Okay, so you have to check for all the 3 reactants. And for the product, okay, you may use one product only. Product is not a problem. Okay, for the product, look for the hint from the question. Dia mesti ada target one product. Okay, because if you are using one product, that means all of the reactant need to be compared with the same product. Okay, you cannot use, okay, for reactant A you use one product, and then for reactant B you are using different product. Okay, you cannot do that. You have to compare with the same product. But the leceh part, the hassle part will be the reactant lah. Okay, so if you have 5 reactants in the reaction, that means you have to proceed for all the 5 reactants. That's the thing. Okay, but so far normally for the limiting reactant type of question, the number of reactants that we have for a reaction is 2. Okay, most commonly we will have 2 reactants. Tapi at most, maksudnya paling dahsyat pun kita ada 3 je. Okay, that is very rare. But it can be asked. Unless dia bagi other extra information, dia tahu dia ada 3, there are 3 reactants, and then it is mentioned in the question, one of it is in excess. Okay, and that means you have to check for 2 only lah. Okay, for the 2 remaining reactants. You still have to use the same approach for that.
Right, thank you, madam.
Okay. Any other question? Alright, so calculate the mass of solute and mass of solvent. Okay, that's the question. Macam senang je kan? Calculate the mass of solute and mass of solvent, which is water, okay, from each prepared solution. Okay, alright, so A, B, and C. As you can see, the information given are all different. Like A, the information is given in mass percent. B, the information is given in terms of molality. C, the information is given in terms of molarity. Okay, so this is a good practice for you guys. Make sure that you understand it by heart. Fahamkan betul-betul. Okay, alright. So kalau A ni, so this you kena describe what does it mean by 1.00% weight per weight of sodium nitrate. Then only you could use the information you can calculate for the mass of solute and mass of solvent. If you couldn't nak crack open this information, okay, you tak boleh nak crack, tak faham what this value define ataupun what does this value the information provided from this value, that means you habislah kat situ. Okay, alright. So maksudnya dekat sini 1% weight per weight of sodium nitrate means it has, kalau kita convert into gram, okay, there is 1 gram. 1% kan? 1 gram of solute. In this case, the solute is sodium nitrate. Okay, 1 gram of sodium nitrate in berapa guys?
100
100 gram of what?
Water.
Are you sure it's water? Go and check the formula ataupun the mass percent, the description for the mass percent. What should we do? Yes.
Sodium.
That's the thing about mass percent ni. Sometimes student confuse gram. That's why you have to specify the entities, the species involved. Okay, in this case, the gram of solution. It's not solvent or whatsoever. It's solution. Maksudnya, in this 100 gram, okay, 100 gram of solution, there is 1 gram of sodium nitrate. So solution apa ni? This is also called sodium nitrate solution. This is the solute only. This is the solution. That means we can also find out the solvent, the number of, the amount of solvent present in the solution. So we can simply minus 100 with 1 gram. So it will be 99 gram of water. Okay, nampak tak information yang ini? Bukan main banyak lagi daripada sini. Okay, alright. So that is the information that we could extract from the percent by mass of sodium nitrate solution. Okay, alright. So proceed with the calculation and try to solve for all the reaction, for all the question that we have lah, for all the checkpoints. Okay, I think that's about it, guys, for today's lecture. Rasa dah mention kan for S19 and S20. So the quiz will be available starting on Wednesday until Friday. Okay, tapi the duration for the quiz is only for 1 hour. So please set your time. Okay, so the quiz will be on UFuture. Okay, especially your connection, please make sure, okay, try as best as you can to make sure that during your quiz, okay, that you have no problem in terms of connection or whatsoever. So plan, okay, plan dari sekarang. Bila nak buat, dekat mana nak buat, okay, you have to plan lah for that. Especially for those who are having connection problem. Okay. Alright, thank you everyone for your attention, and that's all for today. Assalamualaikum.
Madam.
Thank you, madam.
Alright.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.